Hey guys, welcome back to another video. As you may know, I recently made a 3D printed crawler lure. I had this lure on display at the open source event at my booth. So instead of just showing the lure by itself, I wanted to create something that will demonstrate how the lure moves through the water. And so I decided to make an automaton mechanism to mimic the lure's movement. I think the idea came to me while I was scrolling through this guy's Instagram. He makes a lot of really fun and interesting automata. Once I felt I had adequate inspiration, I began the process of 3D modeling the first iteration in Fusion 360. I purchased these metal rods and metal clips from Amazon and printed out all the parts so that I could start assembling. I cut 4mm thick dowel sticks for the mechanism arms. After assembling it and testing it out, it was very clear to me that it was not going to work. The lure kept falling forward and the mechanism arms didn't move the lure wings the way I needed them to. In fact, the movements were very erratic and inconsistent. So I went back to the drawing board and searched the internet for a better solution. I was able to find these mechanical animal designs by Stephen Conine on Thingiverse. The mechanism making the groundhog go up and down seemed like a good solution for making my lure wings go up and down. I then made my design by mirroring the groundhog mechanism and adding a gear and crank handle system. I used this gear generator web app to figure out the ratios of my gears. I then modeled the gears in Fusion 360 using an add-in called Spur Gear. One of the steel rods had to be cut shorter in order to fit into the mechanism design. After printing out the second iteration and testing it out, I noticed that the lower wings were slipping out of the clips after cranking the mechanism a few times. The movement while cranking was also not very smooth and was kind of janky. I didn't get footage of these issues because it was the week of open source already and I was stressing out trying to get this mechanism finished before the event. But basically it was clear that the metal clips weren't able to hold the lure properly and that the lure needed to be attached to the mechanism in a different way. Eventually I came up with the solution using additional 3D printed wing rests, wire loops to hold the wings, and a middle wire structure to keep the lure upright and more centered. I attached the middle wire structure to the mechanism base using hot glue. It was a bit difficult to crank the mechanism while it was resting on a table because the arm was too low, so I made an extended base platform to position the arm higher. I also added recesses at the bottom for non-slip stickers to help prevent it from sliding on a surface. Thankfully, I was able to get the mechanism working before the event. Unfortunately, it did break once or twice during the event, but luckily I was able to troubleshoot and repair it. The first problem I had to fix was that one of the hot glue blobs, keeping the middle wire structure attached to the base, came off. Thankfully, I was able to glue it back into place using super glue, but then suddenly the mechanism was not cranking as smoothly as it once did. Another problem was that the top gear started sliding over the top metal rod instead of gripping and rotating it. Luckily, I had figured out a way to fix the problem, but I did need help from the guys at the repair booth at Open Source. They helped me cut off this part so that I would be able to put super glue on the gear and rod connection. They also gave me some motor oil to dab onto the connection between the back lower wire loop and the middle wire structure. This made the mechanism move smoothly again, and it worked well for the rest of the event. If you're interested in finding out what the open source event was like, please check out my previous video. Anyway guys, I hope you enjoyed this video. If you did, please comment, like, and subscribe, and I'll catch you in the next one. Bye!